Hello, welcome to Unit 1, Lesson 4. We will start to talk about parabolas and equations for them. In the meantime, you will notice that on your notes packet, problems 1 through 8, I assigned as homework. So we're not going to go through 1 through 8 here. They were really reviewed from Unit 1, Lesson 3. So you'll see that after we do this general form and vertex form of the equations of a parabola, we're going to skip problems 1 through 8 and just continue on with the notes, the newer material. All right? So here we go. Quadratic functions and transformations. All right? Our objective is to identify and graph quadratic equations. And really, a parabola, by now you should know this, is really the graph of a quadratic equation. Parabolas are our smiley faces, okay, or our frowny faces. All right? Those are our parabolas. Okay? And there are really two ways you can represent the equation of a parabola. All right? The first way is the general form. We are used to this since Algebra 1, 9th grade, 8th grade, who knows, depending on what you took, what year. All right? The general form is y equals a times x squared plus b times x plus c. That's our general form. All right? This is what we're used to. This is what we're comfortable with. We like this. Okay? But there's something called a vertex form. And because it's newer, we tend to try to shy away from it. But it makes things a lot easier. All right? And the vertex form goes as follows. Y equals a times x minus h squared plus k. Now, what freaks people out? Well, we have an a in both of them. We have an x and a y in both of them. But now there's this h, there's parentheses, there's a k. Freaks people out. But the whole basis of this new equation is the word vertex. As you know, the vertex is either the high point, if it's open downward, that's my vertex right there. That's the high point. Or it's the low point, if the parabola is opening upward. And that's really a critical point when it comes to parabolas. All right, if we know the vertex, we can find out a lot and pretty much graph the parabola on its own. So what's so special then about this? The vertex is right in the equation. Whatever is in for your h and k is the vertex. All right, that is sweet. Now, be careful, because just like when we used to move parabolas, right? We shift them left, right, up, or down, or just moving any graphs, our transformations that we're doing. Visca always said, okay, this moves up 6, okay? But anything inside the parentheses always seems to work opposite. So if I see -3 and I'm moving left or right on my graph, I think the negatives are to the left. But no, it's in parentheses. It's the opposite. So this, when it's telling me move left 3, I would actually move right 3. Now, again, we have a value in parentheses here. All right? I want the h, not the negative with it. I got to flip the sign. For example, if I was going to find the vertex, let's make it a quadratic, okay? If I was going to find this vertex here, it's not -3, 6, okay? Because this is my h, this is my k. It's +3. I always got to flip the value inside of the x. So if it was +3 on the inside, if this was a +3, then I have to flip it and make that -3. Okay? So anytime we're inside parentheses, remember, you got to think it's reversed. It's flipped. Okay? And whether it is in general form or vertex form, we really got to understand that the parent of the quadratic function is always just x squared. It might move left and right from there. It might move up and down. It might flip over the x or the y axis. It might increase at a faster rate and vertically stretch. It might increase at a slower rate. and vertically compressed, so it will be wider. But all in all, it all goes back to this, okay? You should be comfortable with parabolas. So, speaking of comfort, let's work with the general form of the parabola first. All right? Example 1 tells us we need to find the vertex of the function, and they give us this equation right here. F of x equals x squared minus 4x minus 6. So the million-dollar question is this. How do I find a vertex? In an effort to make you feel more comfortable with the vertex form, which we will work with later, the vertex form, the vertex is literally right in the problem. It is not in the problem here for the general form. We have to actually do some calculations to get it, and they're simple, so don't worry. I say calculations and people start to freak out. So, here's what we got. Okay. How do I find the vertex of a parabola, which is the min or max point? Now, you should know basics. When I need a vertex, I need a coordinate. Okay, they're looking for a point. I need an x and a y value. All right? So, how do I find my x value? My x value is negative b over 2 times a. All right? Write that down, get used to it, get cozy with it. So that gives me 1 point. What about my other points? My y. Once I have x, I just plug whatever x is into the equation. And that's how I get my y. All right? So let's go ahead and do that right now with this. You may be saying to yourself right now, this guy, I see a b, I see an a. What are those? Where do those come from? Just like using the quadratic equation. Remember this, negative b plus or minus the square root of b squared minus 4ac all over 2a. Whew, that's a lot. They're the same values that are what I use here, meaning, all right, my a value is whatever in front of my x squared. Here happens to be 1. So a is 1. My b value is what's in front of the x, okay, including the sign. So b is negative 4. And for our case, we don't need the c value, but just get in the habit. If you're going to write down a, you're going to write down b, write down c. C is a number by itself. Besides, if you don't write these down, sometimes you'll quickly look at the negative 6 and put it in for b. I have students that do that all the time, but if you write it down, you have it right there. All right, so let's start. Let's get our coordinate. Okay, let's figure out what x is first. Well, I know it's negative b all over 2a. Visca likes to put parentheses anytime we're subbing in for anything. Negative b all over 2 times a. My b is negative 4. My a is 1. All right, when I negate a negative, it turns positive. 2 times 1 is 2. Look at that, k. That's my x-axis right there. Excuse me, that's my x coordinates of my vertex right there. So right now, I know x is 2. Done. What about the y? Well, my y, I take my x value and just plug it in to the function. So this is my original function, okay? Again, I use parentheses for the variable I'm substituting in for. So it's x squared, this first one, minus 4 times x. That's the second one, minus 6. And a 2 goes in all those parentheses because I'm substituting it to it. 2 squared is 4, minus 4 times 2 is 8, minus 6. If I combine those, I get negative 10. That's my y. So, what's my x and my y? Negative 2 is x. Negative 10 is y. So I want to write it like it's a coordinate. I shouldn't just leave it like that. I should say 2, negative 10. That's my coordinate of the vertex right there. Simple math. It's simple math. Quite literally, you're negating your b value and you're doubling or multiplying by 2 your a value. And you just put them in a fraction. All right? Then how do I figure out the y after I get that x? I literally just plug it into the equation. All right, so you see all this stuff. It's not bad. It's not bad at all. And if the numbers get big, and you have a calculator, use it. At least use your calculator to check. All right? All right, so they're going to give us a word problem and essentially ask us the same thing, the vertex, and then we're going to find other information along the way. All right? So example 2 says, the height of an object, which we will call h of t, is determined by the formula h of t equals negative 16t squared plus 256t, where t is time in seconds. Okay, I can see I can feel a lot of you starting to squirm. Will the object reach a maximum or minimum? Explain your reasoning. What is the max or minimum? Does the x value of, or what does the x value of this point represent? What does the y value of this point represent? All right, well, let's break this down easy. They give us a quadratic. They want to know if it's a min or a maximum. Okay, well, I can tell you right from the get-go, if I wanted to, I would graph this to see what it looks like. All right, I would graph this to see what it looks like. But there is an easier way. All right, whatever my a value is, that's going to tell me whether I have a min or a maximum. Let me explain. My a value is whatever in front of my x squared. In this case, I have t squared. All right, in this case, I have t squared. My a is negative 16. If my a is less than 0, okay, it opens down. And if it opens down, that means I have a maximum point, my vertex. That is the tallest point. If a is greater than 0, that means it opens up. Here you go, that's a smiley face, right? That means my vertex is a low point or a minimum. This would be a minimum here. This would be a maximum here. So they're asking me, will the object reach a min or a maximum? Since this is our situation, our parabola is going to open down. So my vertex is going to be a maximum. So first thing I'm going to write here is maximum. And then it says explain. Explain means you need to use your words, not math. Guess what I'm going to say? Since my a value is less than 0, it's a max. Instead of it's, really I should put vertex. The vertex is a max. I mean, I think they should understand what you're saying, but never leave it up to them to interpret what you mean, say what you mean. Okay, the vertex is a maximum. Since a is less than 0, the vertex is a maximum. There's your explanation. All right? So we did our 2 things here. We answered this one. Is it a min or max? Done. We've explained our reasoning behind it. Done. So now they're going to ask us, okay, I'm going to erase this writing on the left here. Now they're going to ask us, what is the min or max? All right, we're going to do the same thing we just did here, okay? We cannot forget this. When we got the general form, okay, that's how we're going to figure out our vertex. So let's take a look at here. My vertex, my a value is negative 16. My b value is, oh my goodness, 256. And my c value, I have nothing there. So it's 0. So let's actually figure out the vertex, shall we? So I'm going to say that my x value is negative b over 2a. And again, I like to use my parentheses for substitution. All right? My b value is 256. Right? My a value is negative 16. So I'm going to do this. I get negative 256 over negative 32. Well, I know a negative divided by a negative is positive, and I believe that's going to go in 8 times. If you don't trust me, and you know what, sometimes I'll check my work as well, I will say 256 divided by 32. I'll move this over here a little bit and hit enter, and that is 8. All right? Now, the calculator will also come in handy to find the y value. What do I mean? Well, how do I find the y value now? I take my function, I'm going to use an h here and put in 8 into my function. Why did I use an h? Because that's what they gave me. All right? And my function is negative 16 times t squared plus 256 times t, which happens to be an 8. I'm inputting an 8 in both of my parentheses. Now, this one, you might want to do in a calculator to try to do this in your head. But if you can, hey, good for you, man. Negative 16. And I'm going to type this in just as I have it, parentheses and all. 8 parentheses squared plus 256 times 8. If I hit enter, I get 1,024. No, that is not a mistake. That is actually my answer. I'm going to put this right here just so that I have it. So there you go. My y is 1,024. Okay. So my vertex is my x value followed by my y value, right? Again, they want our vertex, so we got to give them a coordinate. Now, what does that mean? We have now answered what is the max or the min. So the only thing we have left to do is interpret this. What does the x value of this point represent? And what does the y value of this point represent? So what do these mean? All right. And in order to figure that out, I'm going to look at the original equation. Let's not forget, this is the same as y, right? And my t's are the same as x's. Okay? T is time in seconds. So therefore, my x is time in seconds. So this means at 8 seconds, okay, my y, which is h of t, is the height. All right? I'm going to go down here. At 8 seconds, the object reaches a height of 1,024. And I want to make sure my label's correct. Is it feet? The height of the object, h of t, is determined by the formula where t is the time in seconds. They don't give us what the object min or max was. Okay, they don't give us this gives a height of 1,024. So whatever the function is, they didn't give us. If it's feet, it'd be 1,024 feet. If it's meters, it'd be 1,024 meters. If it was inches, it would be 1,024 inches. But not only will it reach 1,024, it will reach a max height. This is a max height. Because remember, we just talked, the first thing we answered was that the vertex represents the maximum. This is the vertex. That's a maximum height. At 8 seconds, which is the x value, my object is going to reach a maximum height, y value of 1,024 feet. Okay. Okay. Let's make things easier. Let's start interpreting this actual vertex form, this new thing that freaks us out. All right? Let's start doing this. All right? And as we start to kind of answer our questions using the vertex form, you're going to start to feel more and more comfortable because it's going to be easier for you. All right? For f of x equals 3, yeah, I don't want to scroll here. Let's scroll that down. For f of x equals 3x minus 4 squared minus 2, what are the vertex, the axis of symmetry, the min-max value, the domain, and the range. Okay? So first I'm going to answer is what is the vertex? Well, you'll see they give us right here the equation. And they say, okay, well, my A is 3, my 4 is H, and my 2 is K. All right? So what's the vertex? My vertex is HK. My K is -2. Okay? My H, you want to say is -4, but remember, anything inside the parentheses flips on us. So instead of -4, it's going to be +4. And of course, that's a point. If it were on the axis, that's the x value and the y value on the axis. So my vertex is the HK in the equation, which happens to be 4, -2. All right? Simple. We didn't have to do -b over 2a to plug in a number. Simple. It's right in front of our faces. Okay. The axis of symmetry. All right? If I have a parabola, let's just review what axis of symmetry is. And here's my vertex at 4, -2. All right? The axis of symmetry is that line that goes right here that makes the parabola look like it reflects over that line. My axis of symmetry is always, okay, in parabolas that go up or down. I'm not going to do any sideways parabolas. It's always the x value of the vertex. So what is that? The x value is 4, isn't it? The axis of symmetry is x equals 4. Put a little semicolon there. It is always the x value. All right? The min and max value. Okay? Now they want to know the min and max. Okay? The min and max is always the y value of the vertex. Those little dash marks means the same word as above. All right? It's always the y value of the vertex. Now, my y value is -2, so it's -2. But here's a question. Is that a min or a max? I need to look at my a value, right? I need to find out if something's a min or a max based on this right here. Okay? Is my a positive or negative? My a value is 3. Since my a value is bigger than 0, okay, I have a happy parabola, okay, which means my vertex is the low point. So it's -2, and that's a minimum. Okay, that is a minimum value. All right, right here. That's the graph. That's a low point. Okay, not bad. Okay, this is actually isn't bad at all. And here's some other things here. Let's go to y-intercept. How do I find the y-intercept? All right, the y-intercept, all I do is make x equal to 0 and solve. All right, well, I see one x here. So I'm going to write the equation and put a 0 in for my x, parentheses, -4 squared minus 2. All right, well, this is -4. If I square it, 16 times my 3 minus 2. That's 48 minus 2. 46 is my y-intercept. All right, if they want the coordinate, that's like saying when x is 0, y is 46. Okay, that should make sense because then we plug the 0 in for our x, and our output was our y, 46. So how do we get the y-intercept? We make our x equal to 0 and we solve. Simple. Domain. Anytime we have a parabola that opens up or opens down, unless they put points at the end of it for some odd reason, your domain will always be from -infinity to +infinity. All right? It will go left and right forever. It will continue to open up and go wider and wider and wider forever. Our range, okay? Now, didn't we say that -2 was our minimum value. That's our ups and downs, our minimum value, right? So our parabola goes from -2 and goes up forever. So we're going to say from -2, and with the square bracket, because I want to include -2, I'm going to go to positive infinity. Okay, my range, if you want to make a note, will always include the min or max value. Always, always, always. If you want to write that down, write that down. My range will always include my min or max value. And then it will either go to positive infinity if it opens up, or if my parabola opens down, it will go to negative infinity. All right? Now, describe the concavity. That's just kind of telling you the way it opens. This opens up. Explain. Since my A value is bigger than 0. We have a positive A value, so it opens up. All right? Now, these last two questions talk about increasing or decreasing. I just want to make a little sketch right now. All right? And if I go to, here's 4, here's -2, that's where the vertex is. And we know it opens up. All right? That's at 4, -2. Now, increasing or decreasing. So, is y growing or shrinking as I go from left to right? So, I'm going to start on the far left side of this graph. And notice my y value is going down. That means my y value is decreasing until it hits 4 on the x. After 4, it goes up. So it is increasing after 4. Okay? So when I write this, I want to say it is increasing, which was the yellow. When x is 4, to forever. All right? Now, some people say, yeah, I include the 4. Technically, at 4, it's not increasing or decreasing. It's right at 0. It is not going up or down. So I like to do this. But sometimes in books, they want to include that. In calculus, you have to do it this way. All right? But I've seen answers for Algebra 2 where it's this way, which bothers me. All right? So over what intervals is f of x decreasing? Well, that's our blue little arrows. From -infinity until it hits 4. Okay? It's decreasing. As I read this thing from left to right. Okay, if you guys want to try this one on your own, go ahead. I would love to do it right now. What are the vertex, axis of symmetry, min, max, y-intercept, domain, and range? Well, vertex, flip the h, -1, k, 4. That's my vertex. Done. You see how I like this? It's easier. What about my min or max? My min or max point is always in the vertex. Okay? My axis of symmetry is always in the vertex. My axis of symmetry is always x equals -1. That's your x value. My min or max, okay? First of all, is this a min or max? My a value is -2. Therefore, a is less than 0, which means the frowny face. It opens down, doesn't it? That means my maximum point. My vertex is on top. So I have a max at, well, what's my y value? 4. Done. I mean, look how easy this is. I just the vertex, the axis of symmetry, the min-max. What's the y-intercept? Well, I'm just going to make my x 0. So I've got -2 times x plus 1 squared plus 4. Yes, I use square brackets instead of parentheses. That's fine. So 0 plus 1 is 1 squared, which is 1, times my -2 plus my 4. This is -2 plus 4. My y value is 2. That's my y-intercept. That's at y equals 2. Or if you want to write it as a coordinate, 0, 2. Easy. That's really the only math we've done so far, calculating. All right? Y-intercept, done. And the domain and range. I said for the domain, if it's opening up or down, which it is, not left or right, not sideways, it's from negative infinity to positive infinity. Boom. My range, okay, my vertex is a max point. That's the tallest it's ever going to be. So the tall end is 4, and it's going to go all the way down to negative infinity. If you don't like the vertex form better than the regular form, for this situation, you got to use it more because, man, this was done very quickly if you understand the concept. Okay?